There is a vast network of objects orbiting the Sun, forming a complex and dynamic solar system that extends far beyond the 8 planets we are most familiar with. While these planets dominate our understanding of the solar system, they represent only a small fraction of the celestial bodies that share its space. Millions, perhaps billions, of smaller objects also orbit the Sun, including rocky asteroids, icy comets, and other remnants from the solar system's formation. Asteroids, for instance, are composed mostly of rock and metal, left over from the early protoplanetary disk that eventually formed the planets. These objects are concentrated in specific regions, such as the asteroid belt between Mars and Jupiter, where gravitational forces prevented them from coalescing into a larger body. Farther out, beyond Neptune, lies another collection of small bodies, including icy objects in the Kuiper belt and scattered disk, which are the distant, cold neighbors of the solar system's planets. Comets, in contrast, are icy bodies that often travel on highly elliptical orbits, sometimes originating in the distant Oort cloud far beyond Pluto. Most of their time is spent frozen in deep space, barely active, until gravitational interactions send them on a path toward the Sun. As a comet nears the Sun, the increasing heat causes its icy surface to sublimate, releasing gas and dust into space. This forms a glowing coma around the nucleus, and under the influence of solar radiation and the solar wind, creates the familiar cometary tail that stretches millions of kilometers into space. These tails are some of the most visually striking objects in the night sky, often appearing larger than planets as seen from Earth. When a comet leaves the inner solar system, the heat subsides, the tail dissipates, and the comet freezes once again, returning to its dormant state in the darkness of space. Most comets, such as the famous Halley's Comet, originate within our solar system, formed from the same protoplanetary material that created the Sun and planets. Their orbits are closed and predictable, making repeated appearances possible over human timescales. Short-period comets complete an orbit in less than 200 years, while long-period comets may take thousands or even millions of years. Studying these comets allows scientists to understand conditions in the early solar system, as they preserve the original materials and chemical signatures from billions of years ago. Their paths, composition, and behavior provide valuable insights into the formation and evolution of planetary systems. However, not all comets and small bodies are native to our solar system. Occasionally, objects arrive from other star systems, traveling enormous distances across the galaxy. On October 19, 2017, astronomers at the University of Hawaii's Pan-STARRS-1 telescope detected an unusual object moving through Earth's neighborhood. Initially thought to be an asteroid, further observations revealed that it was moving at an incredible speed of over 196,000 miles per hour, accelerating into the inner solar system, behavior characteristic of a comet. The object, initially labeled 1I/2017 U1, was later named Oumuamua, a Hawaiian term meaning a messenger arriving from afar and arriving first. This name reflects its status as the first confirmed interstellar object known to have visited our solar system. Oumuamua passed beyond Saturn's orbit by early 2019 and then continued back into interstellar space, leaving behind a trail of scientific curiosity and debate about its shape, composition, and origin. The discovery of Oumuamua suggested that interstellar visitors are likely more common than previously thought, with estimates indicating that one such object passes through our solar system each year. Advances in observational technology now allow astronomers to detect these objects more reliably, enabling a new era of study for interstellar travelers. On July 1, 2025, this capability was demonstrated when the Asteroid Terrestrial Impact Last Alert System, ATLAS, telescope in Chile reported a new interstellar visitor, named 3I/Atlas. This object has since been studied intensively using a wide array of observational assets, including the Hubble Space Telescope, which captured images on July 21, 2025, when the comet was about 277 million miles from Earth. Observations revealed a distinctive teardrop-shaped tail extending from a nucleus estimated to be up to 3.5 miles in diameter. Additional observations came from the James Webb Space Telescope, ESA/NASA's Solar and Heliospheric Observatory (SOHO), and even the Perseverance rover on Mars, all contributing valuable data about 3I/Atlas. Studying this comet as it approaches perihelion, the closest point to the Sun, is challenging because the Sun's intense brightness can damage many telescopes. However, heliophysics missions are designed to observe the Sun closely and safely, allowing scientists to monitor 3I/Atlas as it interacts with the solar wind and radiation. This provides a unique opportunity to compare an interstellar object with comets originating from our own solar system, offering insights into the differences and similarities in their formation, composition, and behavior. 3I/Atlas represents more than just a scientific curiosity. It is a window into the broader galaxy. Interstellar objects carry material from distant star systems, allowing researchers to study conditions beyond the Sun's influence. By analyzing their composition, orbit, and behavior, scientists can infer details about the environments in which these objects formed, comparing them to our own solar system. This also has practical implications for planetary defense, as understanding the trajectories, sizes, and structures of incoming objects enhances humanity's preparedness for any potential impact threats, though most interstellar objects pose no immediate danger. The study of comets, both local and interstellar, reveals the dynamic and interconnected nature of our galaxy. They act as time capsules, preserving material from the formation of distant star systems, while also highlighting processes that continue to shape the solar system. From the icy comets of the Kuiper Belt and Oort cloud to interstellar travelers like Oumuamua and 3I/Atlas, each discovery adds a piece to the cosmic puzzle, improving our understanding of planetary system formation, the behavior of small bodies, and the nature of the galaxy itself. Modern telescopes, space observatories, and missions designed to study the Sun and its surroundings have dramatically expanded our capacity to observe these objects, allowing for unprecedented scientific exploration. The excitement surrounding these discoveries is also a reflection of human curiosity and imagination. Comets have inspired stories, myths, and scientific inquiry for centuries, and the arrival of interstellar visitors adds a new dimension to this fascination. Observing these distant travelers encourages collaboration across the global scientific community, integrating ground-based observations with spacecraft data to capture the most complete understanding possible. Each new object discovered offers not just knowledge about the universe, but also a sense of connection to the vast expanse of space, reminding us of the immense distances, complex dynamics, and shared processes that unite star systems across the Milky Way. In conclusion, the solar system is not merely a collection of planets orbiting a central star. It is a dynamic and complex environment, filled with rocky asteroids, icy comets, and occasional interstellar visitors that remind us of the galaxy beyond. Comets, with their brilliant tails and transformative journeys, embody the beauty and energy of the solar system, while interstellar objects like Oumuamua and 3I/Atlas expand our perspective to a galactic scale. Each observation of these objects provides invaluable data, revealing the processes that shape planets and stars, the origins of materials that make up our cosmic neighborhood, and the remarkable dynamism of the universe. As detection methods improve and more interstellar objects are discovered, our understanding of both the solar system and the broader galaxy will continue to deepen, highlighting the intricate, ever-changing, and awe-inspiring nature of the cosmos we inhabit.